In this particular demonstration, we can visualize a rotation of axes by looking at the ellipse that we've got here. And you can see that we do have an ellipse. Here's the equation of that ellipse as well. And you can see that there is a cross product term, the 6xy. The goal of rotation of axes is really about trying to redescribe the shape using a different basis so that the equation for the conic is simpler. So again, the goal would be to try and eliminate that cross product term, that 6xy in this particular equation. And it should be clear that there is in fact a set of axes that would cut through the vertices of our particular ellipse here, and we can turn that on so we can see where those axes would be. So again, our goal now is essentially to describe the same shape, the exact same ellipse, but with respect to this new basis. And so we can do that, and that's part of the process. And then there's also determining this angle of rotation from the original axes. And in this particular applet, we can rotate the axes around here so that they line up with the vertical and horizontal. And when we do that, you can see the new description for the equation here is something that is absent of that cross product term. So we did get that simpler version of the particular equation here. Although in this particular demonstration, it appears that the axes are rotating to line up with the x and y axes. That's not really what's happening. But it does give us a sense for what that rotation is, and you can see here that the angle looks like it's about 25 degrees to rotate that back to align with the old system. So in other words, our rotation is about 25 degrees off from the XY plane, or for the XY axes rather. So that should give us a little bit of an idea about how we can visualize rotation of axes.